So let's take a look of example 2. So this is very simple question that we have to take a look at. So here we should find the limit of f of x equal to L as x approaches 2 from the right, and also the limit of f of x as x approaches 2 from the left. As you can see from here, the 2 power negative is the limit from the left, and then the 2 to the power positive is finding the limit from the right, as I've already explained. So the function is f of x equal to x squared plus 4x minus 12 over x squared minus 2x if x is not equal to 0, right? If x is not equal to 0. And then the other one is 6. Another function is 6 if x is equal to 2. So this is basically a piecewise function, and I believe that during your function class you have talked about type of function. So this is a piecewise function, and we are going to find the limit of this function. So basically the point that we are approaching is 2, but when you look at the first function, the condition 2 is not included, right? 2 is not included, and the second one, 2 is included because x is equal to 2. So when we are doing the neighborhood analysis, when we plug 2 into the function, the first function, you can see that we are going to get what? 0, because, or maybe indeterminate, let me say that way, because 2 squared plus 4 times 2 minus 12 all over 2 squared minus 2 times 2. So the top one here will give me 4 plus 8 minus what? 12 over 4 minus 4, which is what? 0 over 0. So in this case it is indeterminate form, right? And we don't like it that way, you get me? So someone may say that this limit does not exist, but you can't actually say that as far as you have not done any neighborhood analysis, or you can't conclude with that in that situation, since you have not done any neighborhood analysis for the function. So since x is not equal to 2, based on our previous definition, we said that when you are doing the neighborhood analysis, it's not necessary that you should make x equal to 2. That's why the condition even tells you that x is not equal to 2. So doing the neighborhood analysis, we are going to use the tabular approach or the numerical approach, right? So this is something simple to do. So for this one, you can get your simple table, or it depends if you can even keep track of whatever you are doing. You can decide not to use table, but I prefer using the table because that one becomes easier to follow. So for this part, you can label your here x and here f of x. So the f of x stands for your function over here, and then the x is the x values which will be approaching 2 from the left and from the right. So for this part, we will take the first one, which is x approaches 2 from the right, x approaches 2 from the right. So if f approaches 2 from the right, I remember the last time I told you that when you are approaching 2 from the right, you pick a value which is somehow close to 2 from the right. So in this case, you pick 3 from the right. So if you are picking 3, we have 3 over here, and then what is the interval that you want to give? Do you want to give any interval of 0.1? Do you want to give an interval of 0.2? Or how do you want your interval to be like? So in this case, I would like to give an interval of 0.2. So that means that my next value will be 2.8 because I'm approaching 2 from the right. So 2.8, my next value will be 2.6, right? 2.6, my next value will be 2.4. 2.4, my next value will be 2.2. Yeah, I think this piece is small, so it depends on how you write. Okay, I think let me continue here. Yeah, so my next value, I have 2.2, and let's get our next table here, and then the next value that we want to approach is maybe 2.001. so this means that we are not making x necessarily be true, right? So let's do the analysis for it. So at 2.0, or let me start from the top one. So at 3, right? At 3, what is the function value? At 3, what will be the function value? That's what you need to analyze. So at 3, we are going to get 3, because when I put 3 here, 3 to the power 2 will give me 9, right? And then plus 4 times 3 is 12, right? So 12 will cancel this 12 over here in case I'm putting in 3, so I'll get around 9 over here, and then the denominator, 3 to the power 2 is 9 again, then minus 2 times 3 is 6. So basically we are going to get 9 over 3, of which nothing, we are going to get 3. So when you put 3 into this function, right, this function over here, we are going to get 3. So at 2.8, we are going to get 3.142. We are going to get 3.142. At 2.8, we are going to get 3.142. At 2.6, we are going to get 3.307. 3.307. At 2.4, we are going to get 3.499. 3.499. Pardon for my handwriting. 3.499. And then at 2.2, we are going to get 3.726, and then at 2.001, we are going to get 3.999. So as you can see, as we are approaching 2 from the right, you can see that the function value, which is f of x, is approaching what? A value which is 4. It is approaching a value which is 4. So in this case, at 2.001, it is approaching a value which is what? 4. So let's do a neighborhood analysis for the left, which is doing the left-handed limit, and I believe it's already even in the question. Doing it as x approaches 2 from the left. So because there's no space here, let me do that one over here. So let me get my table as usual, and then you write your x value, x here, and then the f of x here, so which is the function value. So since we are approaching 2 from the left, we pick a value which is close to 2, so we analyze, or we do the neighborhood analysis from there. This is a term that I like using it because Joe Menz is one of my favorite teacher or lecturer that I like most. I enjoy his class during my engineering calculus class. So basically, for approaching 2 from the left, that means that we are picking a value which is close to 2 from the left. In that case, I can start from 1. If you are doing it and you want to start from 0, it's also allowed, depending on the interval that you want to give it, right? So I'll start from 1, and then from 1 I'll go to 1.2. I'm also giving the interval 0.2 as usual. 1.2, 1.4, I'll have 1.6, right? And I'll have 1.8, and then yeah, I have 1.8, and then finally I have 1.99. Okay, let me add another 9 so that it will be very close to 2 but not equal to 2. So let's evaluate the function values at these points. So at x equal to 1, this is the function, yes. So at x equal to 1, you can see that the function value is 7 rather. And then at x equal to 1.2, the function value becomes 6. At x equal to 1.4, yeah, the function value becomes 5.286. And then at x equal to 1.6, the function value becomes 4.75. At x becoming 1.8, the function value is 4.33. And then at x becoming 1.999, the function value becomes 4.002. So as you can see here, evaluating the limit from the left here and then from the right here, you can see that they are all approaching a particular value, which is what? 4. But look at it, when you plug in 2 directly, we are going to get an indeterminate form, which means that it's undefined, and now someone will just predict that it is the limit does not exist, of which we'll talk about it later. Or we'll say that the limit, they are not approaching a particular value. But when we did the neighborhood analysis, you can see it yourself that it is approaching a particular value, which is what? 4. So this means that this particular limit exists. Okay, so I know that you have get a better understanding, or you have gained a better understanding in doing a neighborhood analysis for the one-sided limit, which is the x approaches 2 from the right and x approaches 2 from the left of the piecewise function given. So this is another example. You can pause the video and try, right? This is another example, but for this example they are asking us that we should find the limit of the function r of x as x approaches 3. I will recommend that you do the left-handed limit analysis and the right-handed limit analysis for this particular question. But let's look at something here. If you look at the direct substitution approach, what do you think it will happen? If you look at the direct substitution approach, what do you think is going to happen from here? So for this, I'm not going to solve for you, but I'm doing a little bit of explanation so you get to understand it. So for this, what you need to do is that when you place in -3, you can see that the -3 all square will give us 9, right? The -3 all squared here will give us what? 9. It's like -3 times -3 minus into bracket -3 will give us positive. So in this case here will turn into plus. So when I add them, it's going to get 12 and it'll cancel out with this 12. And here, if it becomes -3, I'll get something indeterminate, 0/0, of which we don't like that. So in this case, don't go ahead and conclude that the limit does not exist. I'll ask you to do a neighborhood analysis for that to see the particular number that it is approaching. If you get to know the particular number that it is approaching, then you make or you draw your conclusion from there. So I'm giving you the final answer. The limit will be approaching -7. It will be approaching -7 when you do that neighborhood analysis. So please do well and then use this as a practice and confirm your answer from there. I think practice is the only way that can get you better and better.